second holiday video for Pure Maths 3, and today we're looking at a past exam question on trigonometry. And in this question you're going to call upon some knowledge that you have from previous years, a bit of pure maths knowledge of your identities. You're also going to call upon your knowledge of the sine addition rule as well, and also how to solve trigonometric equations. So let's get straight into it. We have to express 24 sine theta minus 7 cosine theta in this r sine bracket theta minus alpha form. My first step in solving these is I'm just going to remind myself of what r sine theta minus alpha looks like. And I can say, using my sine addition rule, that that is equal to r sine theta cosine alpha minus r cosine theta sine alpha. Okay, and you might be thinking, what? How does that work? Okay, let's have a look at this. You'll notice we've got a sine theta here and a sine theta in the question. Okay, and here we've got a cosine theta and a cosine theta in the question. The next step is to go, all right, what's this 24 business? Well, you've got the sine theta for the first term and it's 24 sine theta. So that means that r and cosine alpha, r times cosine alpha must be 24. And if you look at the second term, r and sine alpha must be 7. Since you've got a cosine theta here, it's a minus 7 cosine theta. So we can say that r sine alpha is equal to 7. And at this point, we're just going to use some basic maths. So we'll go back to blue here. I'm going to square both left-hand sides and add them together, and square both right-hand sides of these two equations and add them together. So I'll have r squared sine squared alpha plus r squared cosine squared alpha is equal to 24 squared plus 7 squared. And then I'm going to factorize. Now when I factorize, I hope you can see that we can take an r squared out here, and in the bracket we're going to have sine squared alpha plus cosine squared alpha is equal to 24 squared, whoops, I should have had a 7 squared on that last line, plus 7 squared. And you know from Pure Maths 1 that sine squared alpha plus cosine squared alpha is equal to 1. So now you know that r squared is equal to 24 plus 7 squared. That means that r is equal to the square root of 24 squared plus 7 squared, and if you work that out on your calculator you'll find that that is equal to 25. And now we're going to work out what alpha is equal to. So we're going to take the red and green equations here, and we're going to pop the green over the top of the red. So r sine alpha over r cosine alpha is equal to 7 over 25. Now you can hopefully see that we're going to cancel out our r's. R divided by r is 1. Sine alpha over cosine alpha, using your pure maths identity from Pure Maths 1, is simply going to be tan alpha. So we say tan alpha equals 7 over 25. And from there it's easy enough to work out using your calculator that alpha is equal to 16.26 degrees. At this point, we can write our final answer to the first part of the question. We're expressing it in the form of r sine theta minus alpha, so we say r is 25. So we've got 25 sine theta minus the 16.26 that we worked out in the first just a few seconds ago. So there we go. That is the first half of the question. The second half says hence. Now when you read the word hence, this is telling you, given what you've just worked out, use that. So we're going to use this in place of the 24 sine theta minus 7 cosine theta. So therefore we can go, well, this is equal to 17. Okay, and then we can say sine theta minus 16.26 is equal to 17 over 25. We get rid of the sine from this side by doing the inverse sine to both sides, and we'll have inverse sine here of 17 over 25. And that gives me that theta minus 16.26 is going to be equal to, that's 42.4 if you check that on your calculator. Now, the question asks us to find the smallest positive value for theta between 0 and 90. So on our graph here, we're going to have something around here, and this is clearly going to be the smallest value for theta minus 16.26. So to get theta by itself, I add 16.26 to this, and to one decimal place, I'm going to have theta is 59.1 degrees. Well, I hope that helps you solve this question if you're having any trouble with it, and good luck with the other ones. Take care.